Hello everyone. What we're going to focus on is solving equation with unknown quantities in the index. Now the rule that governs this is that given that a is raised to the power of n is equal to a is raised to the power of n, therefore m is equal to n. What does this mean? When the bases are the same, right, we simply equate the powers. Right, so this is basically what this is saying here. So we are going to use this rule to solve questions. So the first example that we're going to look on is A, which says that p to the power of x is equal to p to the second power. So we know that we have p, right, which is raised to the power of x, is equal to p, which is raised to the second power. Now note here that the base are p, so the base are the same. The rule says if the base are the same on both sides of the equation, then we simply equate the powers. So therefore x is equal to 2. Easy as that. Now for the second one, we have 2 is raised to the power of 3x, all right, and this is equal to 8. So at this stage, when you look at the equation that we have, the base here for the first term is 2, which means that we want to rewrite 8 with a base of 2. Now 8 with a base of 2 is just 2 to the third power. Right? So if we rewrite 8 in index form, that would be 2 to the third power. So therefore, on the left hand side, we still will have our 2 raised to the 3x power. So note here that the bases are 2. So the bases on the left hand side is equal to the base on the right hand side. They are the same. So when we have this situation, we simply equate the powers and solve for the unknown. So it's going to be 3x is equal to 3. Now we want to solve for the value of x. Because we are multiplying by 3, we're going to do the opposite, which is to divide both sides by 3. Remember, whatever you do to one side, you have to do it to both sides. So here, 3 will cancel out 3. What we're left back with on this side is x. And 3 divided by 3 is just 1. So therefore, x is equal to 1. Now, let's look at our third example. Third example that we have is 3 raised to the power of 2x plus 1. And this is equal to 81. Alright? Now again, the base of the first term here is 3. So which means that our objective is to rewrite 81 with a base of 3. So we want to rewrite 81 in index form, but we want the base to be 3. And that would be 3 to the fourth power. Alright? So 81 is the same thing as 3 raised to the power of 4. So we put back what we have here, which is 3 raised to the 2x plus 1 power. Now at this stage, the bases are the same. Both bases are 3 here. So at this stage, we can simply just equate the powers and solve for x. So it's going to be 2x plus 1 is equal to 4. And from here, what we're going to do, we're going to add the additive inverse of -1 to both sides because we want to get rid of this +1. So we can subtract 1 from both sides of the equation, right? So if we subtract 1 from this side, and we also subtract 1 from this side, then positive 1 minus 1, that's going to give us 0. So what we're left back with here is just 2x is equal to 4 minus 1, that's going to give us 3. At this stage, we are multiplying this x by 2. We're going to do the opposite, which is to divide by 2. But because we divide one side by 2, we have to divide both sides by 2. Alright, so here 2 will cancel out 2, leaves us with x, and x is therefore equal to 3 over 2, or 1 and 1/2. Alright, now to our next problem. Next one example that we have is 2 raised to the power of x plus 2, and this is equal to 16. Now our first objective, we want the base to be the same, but we have to look at 16 and rewrite 16 in index form using a base of 2. Right? So 16 is the same thing as 2 to the 4th power. Right? Remember that the power tells us how many times we must multiply the base. So this 4 is saying that we must multiply 2 by itself 4 times. And if you multiply 2 by itself 4 times, that will give you 16. So here, we write back what we have on the left hand side, which is 2 raised to the power of x plus 2. At this stage, you note that the base of the term on the left is 2, and the base of the term on the right is also 2. That means the base are the same. When we have this situation, the rule is we equate the powers and just solve for x, or the unknown. So therefore, x plus 2 is equal to 4. Get rid of this plus 2, so we can subtract 2 from both sides. So we can subtract 2 from both sides. If we subtract 2 from both sides, note here positive 2 minus 2, that's 0. So what we're left back with is just x. And 4 minus 2, that's just 2. So therefore, x is equal to 2. Alright? Now to the next problem. What we have here now is that we have 3 is raised to the power of x minus 5. And this is equal to 27 raised to the power of 2x plus 1. So now, this might look complicated, but it is the same concept. So here, we want to write 27 in index form with a base of 3, right? Because the base of the first term here is 3. So we're going to write back this term here that we have on the left. So we're going to have 3 raised to the power of x minus 5. Put back our equal sign. And now we need to write 27 with a base of 3 in index form. And that's going to be 3 raised to the 3rd power. But we must remember that 27 was raised to the power of 2x plus 1. So we're going to open a bracket beside the power 3 here. And we're going to write 2x plus 1. So that's how you would do this problem here. At this stage, note that the bases are the same. So we just simply equate the powers. So what we will have here, on the left, we would have x minus 5 is equal to 3, open bracket, 2x plus 1, close bracket. At this stage, we're going to solve for x. But before we can solve for x, we need to remove the bracket. Now, we have to apply the distributive law in order to remove the bracket, which states that whatever is outside of the bracket, we must take it to multiply each term inside of the bracket. So let me draw some arrows to show that. We're going to take the 3 here to multiply the 2x. Then after we finish that, we're going to take the 3 to multiply the positive 1. Alright? So let's do that. So we keep our equal sign here. So 3 times 2x, that's going to give us 6x. And 3 times positive 1, that's going to give us positive 3. And that's how you would get rid of the bracket there. So on the left, we still have x minus 5. Now at this stage, we want to group the like terms, right? So I want to group the terms with x on the left, right? So what you're going to do, I'm going to write back my first term that I have, which is x. So here, as I was saying, that I want to keep the x term on the left hand side. So which means that the focus is this positive 6x. So how can I make this positive 6x become 0 on the right hand side? I can subtract 6x from both sides, right? So if I subtract 6x from this side, that's going to give me 0 here, but I need to show it on this side, so I'm going to have x minus 6x is equal to the 3 that I still have here, which is this positive 3. At this stage now, I don't want this minus 5 here. I want it over on this side. So what I can do is to add 5 to both sides. So if I add 5 to this 5, minus 5 plus 5 becomes 0. So I need to put it on this side to show that it's going to be 3 plus 5. And here, by doing that, note that the like terms are on one side. Now I have x minus 6x, that's going to give me minus 5x, which is equal to 3 plus 5, that's going to give me 8. And at this stage now, I need to get x by itself. This x is being multiplied by negative 5, so I'm going to divide both sides by negative 5. I'm going to divide this side as well by negative 5. Negative 5 will cancel out negative 5. What I'm left back with is just x is equal to negative 8 over 5. And that's it. Now to the next example. Here we have 8 is raised to the power of 2x, which is equal to 1 over 64. So 1 over 64 is the same thing as 64 to the negative 1, right? And on our left hand side, we still have 8 raised to the power of 2x, right? Now, because we have 8 raised to the power of 2x, and 8 is the base here, we are going to rewrite 64 to the negative 1 with a base of 8. Now, you would have known your square table, so therefore 8 is 64. So 64 can be written as 8 squared, right? But remember that this square should multiply the power that you have here, which is negative 1. So we're going to put a bracket and put negative 1 in there and close our bracket. And we still have 8 here raised to the power of 2x. So at this stage, both bases are 8. So the bases are the same. So what we need to do is to just equate the powers. So therefore, 2x is going to equal to 2 times negative 1, which is just negative 2. And at this stage, we want to get x by itself. 2 is multiplying x, just divide both sides by 2. So the 2 will cancel out this 2 here. What we're left back with is just x is equal to negative 2 divided by 2. That's going to give us a negative 1. And we're finished. Now we have one more that is similar to this one. So our final example here, we have 25 is raised to the power of 2x, and this is equal to 1 all over 125. Now, what we can do is to keep what we have on the left hand side, so we're going to write it back, which is 25 raised to the 2x power, right? And then we're going to use up our laws of indices, which is the inverse law, to rewrite 1 over 125, and that is the same thing as 125 raised to the power of negative 1. Now here we have 25 here as the base. Now the question could be, can you rewrite 125 with a base of 25? The answer is no. So that means we have to think deeper. How can we rewrite 25 in index form? We can rewrite 25 as 5 to the second power. So let's do that. So 25 here is the same thing as 5 raised to the second power. But this 2 must use to multiply the power that we originally started out with, which is 2x. So introduce a bracket and we'll put 2x in there and close our bracket. Now our next question, how can we rewrite 125 to the negative 1 using a base of 5 in index form? Now 125 is the same thing as 5 raised to the third power, and in bracket we have negative 1. Now remember that the bracket here implies multiplication. So note the bases are the same. 5 is the base of the first term here on the left, and 5 is the base of the second term here on the right. So the bases are the same. The rule is equate the powers and solve for the unknown. So here we're going to have 2 times 2x is equal to 3 times negative 1. So 2 times 2x, that's going to give us 4x, which is equal to 3 times negative 1, that's going to give us negative 3. And here, in order to determine the value of x, x is being multiplied by 4. We're going to do the opposite of multiplying by 4, which is to divide both sides by 4. And we get x by itself. So if we divide both sides by 4, 4 will cancel out, and what we have here is x is equal to negative 3/4. And we're finished. Thank you for watching, and do enjoy the rest of your day.